Hello, advanced algebra students. I just want to say if you're struggling with these problems, I'm sorry. But if it makes you feel any better, I am struggling too. This is literally the third time I'm going to record this video because the first two times I forgot to press record. That's right, twice. It's a day. Here we go. The Pythagorean theorem found on the GED formula sheet relates the three side lengths of a right triangle. So triangle is just our three-sided shape, right? And a right triangle is one that has a perfect 90-degree angle, like a perfect angle of a house, your floor to your wall, where A and B are the measures of the two legs of the triangle. Legs refers to the two sides that form that nice L. That's how I remembered. It's a nice, beautiful L around the right angle. Those are the legs, A and B. And legit question, you might ask, which one's A, which one's B? Does it have to be in that? No, it doesn't matter. The two legs are interchangeable. I could have just as easily written A on the bottom and B along the side. And C is the length of the hypotenuse. So the hypotenuse is always that longest side that's across from the right angle. Use the Pythagorean theorem to solve each of the following. Okay, these directions here, that was me just giving you enough information to know which formula to choose if you don't have a geometry background, but that wouldn't be on the GED. You would just see this part of the problem. A right triangle has legs A and B that measure 10 centimeters and 24 centimeters. What is the length of C, the triangle's hypotenuse? And you might not even see the letters A, B, and C in it, so how would you know that it's time for the Pythagorean theorem? Well, the fact that it's a right triangle and we see mention of its three sides, legs, 1, 2 of them, and we're looking for the length C of another side, the hypotenuse. Three sides, right triangle, bust out the Pythagorean theorem. So here is my GED formula sheet. And if you've been with me very long, then you know that I always say that the geometry formulas are up here on the first half of the formula sheet. And I stick by what I said. Most of them, though. This one, for some reason, they didn't put on the top. I don't know why. Why ever they did it, it's down here. Pythagorean theorem is down in the algebra section, and all it says is a squared plus b squared is equal to c squared. It says nothing about triangles, nothing about sides. So mark up your formula sheet, you guys. Draw yourself a little right triangle. Remember that the A and B are those legs forming an L around the right triangle, and C is that side across. So get that on your formula sheet so that while you're doing that mixed review test practice, which you advanced students will be doing shortly, you at least have that much geometry on your formula sheet to remind you, and you'll be prepared for test day. And no, you don't get to bring in your marked up sheet to the test, I'm sorry, but just the act of marking it up and using those markings as you study will help you be better prepared, I promise. And now, hey, it's not geometry anymore, is it? It's just a testing of our algebra skills. Let's do what we always do with the formula, plug in what we know and use it to find what we don't know. So the right triangle's legs measure 10 centimeters and 24 centimeters. Those are our A and our B. And again, it's interchangeable which one's which, but I will just put them in the same order they gave them to me. It doesn't really matter. And now I love you guys, my advanced level students. You're fantastic. You're fabulous. You're wonderful. You're amazing. But sometimes you're too fast for your own good. I don't want to call you lazy, but sometimes you get a little lazy, you guys. You're a little cocky. Let's just call it cocky. Okay. And you just kind of like halfway write things down. But I don't want you to do that, especially on these problems, because dropping squares is a really common issue. Okay. So I'm going to be a good secretary. My A was getting squared. There's a plus symbol from above. My B is getting squared. Everything from up above, I still want to see on your left-hand side. Okay, right-hand side, C squared. This problem, it said, what is the length of C? The hypotenuse. I'm solving for hypotenuse C. And again, I'm a really good secretary who keeps all my symbols so I don't make silly mistakes. All right, now I'm excited. Hopefully you're excited too, because the entire left-hand side now, there's no letters left. There's no variables there. So it's just an arithmetic expression. No, you don't need to know that vocabulary word, but you do need to know that when it's just numbers, you can just plug it all into your calculator. So 10 squared plus 24 squared, and let's simplify that, gives us 676. That's that whole left-hand side. And so that new simpler expression is also going to be equivalent to C squared. And now that we've simplified, it's going to be a lot easier to solve here. Now, another common error is to stop right here. but not for you advanced students. You guys know that what c squared is equal to is not the same as what c is equal to. We need to get rid of this square in order for c to be alone. So I'm going to do the opposite. I'm going to take the square root. Now, I can do whatever I want to an equation as long as I keep my two sides equivalent. So I'm going to jump across the equal sign. I'm going to do the same thing over here. Now, I'm just going to tell you something important for college that doesn't come up on the GED, okay? So if you want to just think about, like, I don't know, butterflies and sandwiches and those happy, happy days when Kate's not talking, you can do that now. But technically, there's two answers here. Technically, when you go to college, you're going to need to put a plus or minus in front of this, because there's two answers when you take a square root of something. There's a positive and a negative answer. But it doesn't apply in the GED test context because this is geometry. I'm not going to have a negative side length. And so you don't need the plus and minus for the GED test. But I just wanted to fair warn you, because you guys, my advanced level students, most of you guys are going on to college. You're going to go to college algebra, and you're not going to get full credit if you can't come up with both the answers when you have equations like this, when they're not in geometry. Okay, all that being said, let's go ahead and look at what it is when it is geometry. Square and square root are opposites. They cancel. C is alone, just like I wanted. And it's going to be equal to whatever I get when I take the square root of 676. So square root's over there in green. I need to hit the green second button, take the square root of 676, and I see it's 26. Another really common student error is to keep that square root symbol around. Don't. You used it up. You did that math. It's not there anymore. Okay. It's an operation, a thing to do. It's been done. But I do have one little thing to consider here, and that is 26 what, right? C was a measure of a side length. So 26 inches, 26 feet. Take a look at the problem. It says right triangle has legs that measure 10 centimeters and 24 centimeters. So this is 26 centimeters. Nice. Next example. Another right triangle has a hypotenuse C of 30 inches. One leg measures 23 inches. Find the measure of the other leg to the nearest 1/10 of an inch. So you say to me, Kate, just bust out the Pythagorean theorem. And I say to you, y'all, because it's the Pythagorean theorem video? Yeah. Why? What about this problem tells me that I need the Pythagorean theorem? Because you won't have any context like this on the GED. Well, here's how I know. We are looking again at a right triangle. Pythagorean theorems only apply to right triangles. It's a relationship between the three sides of a right triangle. So I have to have a right triangle, but I also have to have three sides. Let's see if we do. Well, we have the hypotenuse. That's one of the sides. We have a leg. That's another side. And we're looking for a third leg. Yes, it is time for the Pythagorean theorem because I am trying to relate the three sides of a right triangle. Let's plug in what we know. First thing, A and B were the legs. We know one of the legs. One leg measures 23 inches, but we don't know the other leg. That's what we're finding. So great question, legit question. Which one's A? Which one's B? Turns out doesn't matter. The legs are interchangeable, but I'll just plug 23 in for A. Now, be a good secretary, my dear advanced level students. Don't be too, I don't want to call you lazy. I really don't, but hurried. Sorry. Can you guys tell I'm like scarred from my high school years when I got told I wasn't living up to my potential too much? But yeah, don't be too hurried that you don't copy down the entire left-hand side of your equation or you are going to lose your squares. That's what always happens. Students lose their squares. All right. You're one square short of a right triangle. Okay. So 23 squared plus, and now B is the other leg, right? And that's the thing we don't know. So we should still have B squared. Don't make that other common student error of just always plugging in on the same side without taking any regard to what the numbers mean. Now C is the hypotenuse, and we do know the hypotenuse. So do make sure that you replace C with that 30 value they told us about. And again, don't be so hurried, you lose your squares. And now, unlike the last one, I can't just simplify the entire left-hand side, right? I still have a letter there, so that's not going to happen. But there is a piece of that left-hand side I can make a little simpler. I can do this math, 23 squared, and so I will. 23 squared equals 529, and I've replaced this piece, and I've got to keep whatever I haven't used, the plus B squared, and that's going to be equal to this entire right-hand side. I sure can simplify, and that equals 900. And now that it's a little simpler, it's easy to see that this is a two-step equation. There's b over there, and there's two things to get rid of. I got to get rid of this number 529 and this operation here, the squaring. Now, when I'm solving, I work the order of operations backwards. So I'm going to get rid of anything adding or subtracting with b before I handle the exponents on b. So I'm going to get rid of 529. So in order to get rid of 529, since it's adding or subtracting, I need to try to make it zero out. I'm going to subtract 529 away. And again, I'm writing subtract 529, not because this is a plus, but because I need to get it to zero out. Because if I have nothing plus b squared, then I'll just have b squared. Now I can do whatever I want to an equation as long as I keep my balance. Again, do not shoot yourself in the foot with your poor secretarial skills, you guys. 529 minus 529 does zero out like I wanted. And 0 plus b squared, well, that's just b squared. And that's going to be equal to, guys, don't do all the algebra, the hard stuff correctly, and then get your problem wrong because you subtracted wrong. I'm just going to do this in my calculator. I'm thinking hard enough about the algebra. So 900 minus 529 gives me 371. Another common error. Students, stop right here. Not you, though. You know the opposite of square is square root. I need to square root that sucker to get b alone. And you know to do it to both sides. And you also know now that if you were in your college classes not doing geometry, you would put a plus minus in front. But this is geometry. I'm only going to get positive answers for side lengths. So I can ignore that and ignore the fact that Kate told me that. All right, let's see what happens. Square and square root are opposites. B alone like we wanted. And now this is going to get weird. Are you ready? Are you ready? You're ready. Okay, let's take the square root. So second square root of 371 and watch what your little errant calculator does. Oh, well, that's not what you expected, is it? Yeah. Your calculator prefers simplified radicals over long, ugly, rounded decimals. But you can force it to give you a long, ugly, rounded decimal like you would want in the real world application that we're doing right here by pressing the quick convert button. Just like how fractions and decimals, you can go back and forth between them, you can go back and forth between radicals and decimals. Okay, and I get this whole long, ugly thing. You can see why your calculator didn't want to bust this out. And even this is rounded because technically this is what we call an irrational number, one whose digits go on and on forever. But you don't want it to go on and on forever because there's rounding directions in your problem. Look what it says. To the nearest 10th of an inch. So 10th of an inch is one decimal place. But when I round, I need to consider the next number, the one I'm throwing out, to ask myself if I'm halfway through my digits yet. Because if I'm halfway through my digits, I'm closer to 19.3 than I am to 19.2. And indeed, I am. Anytime I hit 5 or higher, I sure did, 6 is 5 or higher, I'm actually closer to the next number. So B, it's more like 19.3. And use that wavy equal sign to signal to everybody, hey, I rounded. B is about 19.3 inches. Ooh, you guys, I did that video 3 times. I gave myself a headache. Oh, maybe my ponytail's too tight. Oh, I hope you're having a better day than I am. All right, you guys. Happy learning.